Did you pick up an 84 last night? Yes. Okay, should have.
There was no.
Oh.
You're fine. Did you finish all that?
Yeah. Except for the I did so well in the test review.
Oh, wow.
I have no idea.
Where did you put the grade?
It's fine.
No,
If you notice, I'll just tell them.
You're talking about how we did.
I
I
mean,
think we did pretty bad.
No, I think I did terrible. The only thing I ate up was the
And like,
later.
we,
Okay, I'll try to do that.
we always get notes on it.
Just wondering if I did do that.
Oh, no, yeah, we did it last class.
I'm good.
Yeah. No, I still have 100 in this class. They have to do that right now.
I've got,
That's such a long time.
which is, I did not get my homework graded. I think this test grade can drop that. It's gonna be so bad.
Correct. I am so glad you put all those homework grades in first. Because the first grade in there was the best grade. I was going to be screwed.
Sound nice.
And then I was like, oh, I was like,
I just checked. So, no.
guess no minute of silence today. All right, guys. Today we're going to move on to the rest of Chapter 5, which is almost entirely one process called U substitution. I kind of have been mentioning this for a while. I would say probably without debate, this is the most important thing that we do this semester. AP exams typically ask this type of question multiple times, like 4 or 5 times. They definitely test it quite a bit. So today what we'll do is we'll go over some examples together as notes. That's 84. I gave that to you after your test last time. If you did not pick one up, I've got some extra copies over there in the binder, number 84. Then I've split up a book assignment into 2 parts. So today we'll do the first part that has 8 questions, but we will do it together as a group. And then I have 3 Khan Academies for you to do. One is where you're going to practice trying to pick out the U. That'll be the quickest and easiest one. That'll make more sense after we go over the notes. And then one over doing U substitution for definite integrals and one for U substitution on indefinite integrals. So this is the type of question where after I really show you one question, like you will see the full process. After you see 4 or 5 examples, you kind of get the hang of what you need to do. But it's one of those things that you really have to practice a lot. It's like factoring. Like you can kind of get the idea of factoring after a question or 2, but you don't feel comfortable and you're not reliably successful until you practice it a bunch. So U substitution is the same thing. So U substitution is the only thing we're looking at today, and it'll be the majority of next class as well. So as we look through this, there's always some students that doesn't catch on too quickly, but that's okay as long as you try to learn from your mistakes, and so that each question gets a little bit better. I promise it'll be fine. So you'll feel better by the end of the class. Okay, so question number 1 in 84. Actually, before I even go over that one, I would like to ask you guys a question just out to the side, and you don't have to copy this down to your notes. But if I wanted to integrate U cubed du, how would we do that? Okay, so you'd raise the power by 1, divide by the new power, and don't forget plus c. There could be a plus c. That makes sense, right? We've been practicing this type of undoing power rule for a while, correct? If you can do that, this is the second half of question 1. Question 1 looks way harder, it looks more intimidating, but with the U substitution process, we practiced doing that a few times, we're going to make this look the same way as the question I wrote out to the side, which is much easier. So the whole idea of U substitution is it takes an integration question that is a little too much mental juggling to expect us to do this by hand, and we're going to replace this X stuff with U stuff, and then we will work it the way we did that question just a second ago. So out to the side, honestly the biggest or the best advice I can give you is to be consistent with the same thing I'm doing over here. You need to develop these habits and not try to take any shortcuts. Taking any shortcuts to what I'm about to show you is going to make it a more difficult and longer process before you feel comfortable. Okay, so on each of these questions, we are going to have to guesstimate what we think U is. We have to make a guess about a U value. Now again, this gets easier. After you see a few of these, you start to make some pretty good guesses. But U is typically the thing that's trapped under something. Trapped under a square root or trapped under a cubed, like so. I would guess x squared plus 1 to be U because it's trapped under that cube. Sometimes you'll figure out that's not a good guess, but it's not that much work to fix. The second thing you need to compute in every one of these questions is du dx, which basically just means take the derivative of this side with respect to x and then take the derivative of this side with respect to x. Okay, and then the third thing you always need, sometimes you need 4 things over here, but the third thing you always need is you need to solve for du. So even though this du over dx is not really a fraction, it kind of works like a fraction, where we can just multiply that over. So I have made a guess about what u is by taking the derivative of both sides and solving for du. I have what I think du is, and we use these as like puzzle pieces. We're going to try to rewrite this question using this stuff instead of x's. So instead of saying x squared plus 1 cubed, I'm going to say u cubed, because that's how I defined u, as the x squared plus 1. And then the rest of the stuff is a perfect fit this time. The rest is 2x dx. Well, I know what 2x dx is equal to. It's equal to du. So by making those substitutions, I have phrased it in a way that makes a lot more sense in my head. So just like a moment ago, I told you didn't have to write this out to the side. You need to write it to finish this question. But now we can raise the power by 1, divide by the new power. Make sure you put a plus c there unless it's a definite integral. And then there's only one more thing we need to do on this question type, and we're done. Well, maybe 2. U substitution is a process to help you do this, but this question doesn't say anything about u's. You shouldn't have u in your answer. So instead of saying 1/4 u to the 4th plus c, we need to do 1/4 what u is equal to the 4th plus c. Now, the only other thing I would suggest is, especially on high stakes questions, you can always check by taking the derivative. If we brought the power down, these would cancel. We would lower the power by 1, which gives us an x squared plus 1 cubed. And then because of chain rule, we would multiply by 2x. So it's good for you to practice those derivatives too, since we don't get to use them a lot. But again, I guess I solved for du dx, I solved that for du. I use these as puzzle pieces to rewrite the question in a way that's easy to do. I did that, and then I put that stuff back in place of u. Okay, so as I said, it gets easier with each question. So now you have an idea of what we're trying to achieve. So in question 2, again, every question you need to find these 3 things. And if you're taking any shortcut and not writing those down, there's honestly not much I can do to help you. This is not the skill that you want to be taking shortcuts on. But when I look at this, I see the inside is probably 5x. 5x is trapped inside of cosine, so that would be my guess for u. Take the derivative of this side with respect to x. Take the derivative of this side with respect to x. And then imagine multiplying this dx over. Okay, so sometimes we're going to have to do one more step here, but for this question I think this is sufficient. Using this and this, we are going to try to rewrite this so that it doesn't have x stuff, so that it only has u stuff. So in place of cosine 5x, I could say cosine u. Yes?
Sorry, is du 5x or 5?
Oh, I'm sorry, 5 dx, yeah. Thank you. I multiplied over dx. So instead of saying cosine 5x, I could say cosine u. And everything else has to be accounted for. So I need to know exactly what 5 dx is equal to. That's why just make a habit out of doing this, because you're going to need this. 5 dx is exactly du. We can't integrate this if it's got 2 different variables going on. This can't be u and this be an x. That doesn't make sense. We need these to be consistent. This is defining the variable. So now we have rewritten it. This, honestly, if you can undo one step of chain rule in your head, you probably don't need u substitution on this question. But u substitution is really the process that avoids us from trying to do product rule, quotient rule, or chain rule in our head. This process just handles all of that for us. So what can I take the derivative of to get cosine u? Okay, that's one we memorize. And then plus there could be a constant. And then the only thing you should do before you circle this as your answer is the question had nothing to do with u's, so you shouldn't have a u in your answer. Don't say u, put what u is equal to for your answer. And in high stakes questions, or occasionally once in a while, check it by taking the derivative. The derivative of sine something is cosine something, so it gives me the cosine 5x. And then why do I get the 5 as well? Because of chain rule. So again, it's not that you couldn't maybe figure that out in your head, but this process eliminates the guess and check in your head. It allows us to just rewrite it and then plug it back in. Okay, so question 3, I think is going to take one more step if I remember correctly. But I need to start asking you guys questions so I know what to focus on. What would you guess to be u in this question? Okay, I think that's a good guess, because that's the stuff trapped under something, trapped under the fourth power in this case. Okay, what else do I need to solve for every single time? Okay, du dx, which just means take the derivative of this side with respect to x, so take the derivative of that side with respect to x. And what I'm really doing that because I need to know what du is equal to. I need du in this question, so multiply the dx over. Think of it this like a fraction, even though it's not really a fraction. And then based on the last two questions, we were able to use this and this to make this question look different. This time we're going to have to do one more step to this, but that's okay. When I start rewriting this, instead of saying this stuff to the fourth, I could say u to the fourth. Now here's where you need to be careful and where you really need to emphasize this part of the process that I'm trying to get you to do. It's tempting to just slap a du there for the rest of it. Why can't I just put a du there?
It's 2x.
Right, my leftover pieces is 1x dx. Du is not equal to 1x dx, it's equal to 2x dx. So if I do what I did, what's written down, I just put a 2 there that's not supposed to be there. So before I can do that, sometimes you need to do one more step. And again, I know this is going to seem unnecessary, but I promise you it's going to make it easier for you. If you have x dx, write that down. Think about what you're doing to this side. I divided by 2, so that means you need to keep your equation balanced by dividing that side by 2. You are welcome to replace x dx with 1/2 du. Again, that's part of undoing the chain rule process. And if you want to try to rationalize that in your head and understand why it's working, that's great. But u substitution, the whole point of u substitution is so we don't have to do that in our head. So once again, I needed x dx, so I divided this side by 2, and that's how I knew to divide this side by 2. If you don't write this step down, there's going to be questions where you're going to say, where'd the 1/2 come from? Where'd the 1/8 come from? Why is it 3/4 out front? And again, when you make this substitution, everything has to be accounted for. Everything I have is underlined. So now we can finish it. Now, I don't want to go too fast over the second half of the questions, but again, the second half of the questions is really what you've been doing for a while. We could raise the power by 1, divide by the new power, throw a plus c on there. We can multiply those, and please don't leave c in your answer, or I'm sorry, you should plug in what u is equal to. The question didn't say anything about u's, your answer shouldn't have anything to do with u's. U substitution is a process to help us do this without a calculator and without a textbook and all that kind of stuff. And if you had time, you could check that by doing power rule and chain rule. That one's not too bad, yeah.
This might be a stupid question, but why did you put the 1/2 out in front of the answer?
You can put it here if you want to, but it's just like derivatives. It's going to make it half as much, so I just try to simplify the calculus as much as possible and then worry about the constant later. If there's a 12 there, I would just worry about the 12 after integration. So, Okay, we're going to look at one more of these indefinite integrals where we don't have the upper and lower bound limits, and then the rest of the notes will be on that. This one is a pretty, so let's just go ahead and write out the stuff, try to make a habit out of the things we're going to need every single question. Sometimes we need one more. But this one's a pretty hard one to guess u. But does anyone want to give it a shot? Okay, sin x is not it, but no, that's okay. I want you to see it. Don't hesitate on picking a u, because if you pick a u and then you do the derivative and then you multiply this over, sure, you could maybe change this guy to be u, but how are you ever going to get this to be cosine squared? You can't just square part of this side of the equation without squaring the whole thing and not square this side, and then none of that stuff matches up. Everything has to be accounted for. So if you pick the wrong u, it's not a big deal. It just means that you figure out after a moment that these don't look to be the right puzzle pieces, and then reset. So what else could we pick? Okay, I think cosine x is a little bit better pick because remember with trig functions, this means squared. So this cosine is being squared. It's the thing trapped under the squared. So take the derivative, which would be negative sine x. Especially with sine and cosine, y'all need to be careful which direction you're going. When you're integrating, it does one thing. When you're taking the derivative, it does a different thing. Remember, one time when you take the derivative of sine or cosine, you get the negative of the other version, and sometimes you don't. Those back and forth rules, half the time it has a negative, half the time it doesn't. You need to be careful. You don't want to miss the question because of that. Okay, multiply the dx over, and then hopefully we have everything we need to make this substitution. So instead of saying cosine squared, I'm going to say u squared. And then the other stuff I need to replace, and I can't just do close to it, it has to be perfect. I need to replace sin x dx. Well, do I know exactly what sin x dx is equal to?
Negative du.
Okay, close, but not quite. So I know what negative sin x dx is. So make yourself write down what you actually want it to be. Think about what you're doing to the right side so that you do the same thing to the left side. If you want to make a replacement for sin x dx, it's not du, it's negative du. Again, this process is trying to make your life easier. Don't take shortcuts on it. Okay, and then now it's nothing special. We raise the power by 1, divide by the new power, throw a plus c on there, and make sure you plug this stuff back in place of u. And if you have time on a high stakes question, you can always check your answer by doing the derivative. Power rule and chain rule. So typically what students think is hard about u substitution at first is they're a little hesitant about picking out u. But as I showed you, if you pick the wrong u, about 30 seconds later you should see things don't look like they match and you know to pick something else. And then a lot of times, so picking out u is going to be one of the things that takes a little bit of time to feel comfortable with. And then knowing where this negative comes from. That's why if you follow the same way I'm modeling it for you, it takes all of the guesswork out of there, all the uncertainty. Okay, so now we're going to move on to definite integrals, but is there anything specific about 1 through 4 you guys would like to ask? Okay, honestly, definite integrals is about the same thing, but there is one extra thing we need to consider. So we for sure will need to guess a u. We will for sure need to solve for du dx, and we will for sure need to solve for du. And maybe one more, just depending on if those pieces fit. All right, so what do you guess u to be?
X squared plus 2.
Sounds good to me. It's trapped under the cube. Derivative of this side, derivative of this side. Multiply the dx over. This and this, you need every single question. Sometimes we need to go one step further than that. So we start to make these replacements. Instead of dividing by x squared plus 2 cubed, I'm going to say dividing by u cubed. I don't want to have any x's after my u substitution. And the other stuff I need to replace is x dx. I don't know what x dx is equal to, but one step later I will. Divide by 2, so divide by 2. If you don't do that, you're going to have times where you don't understand where that 1/2 is coming from. Force yourself to write this last step. If this is not the last puzzle pieces you need, change it to so it is. Think about what you're doing to this side, because that's what you need to do to that side. That's where the 1/2 is occurring. Okay, I'm going to do one more step, and then I'm going to tell you what's different, because I haven't said anything different yet. So this is like u to the -3, if I rewrite it. So raise the power by 1, divide by the new power, and then we're going to integrate from something to something. Okay, this is what's going to be different. The question says from 1 to 2. Why, or do you have an idea, before I tell you, why I should not be integrating from 1 to 2?
Because it's not an x yet.
Exactly. You need to write this down in words one time. 1 and 2 here is if you're talking about x values. I'm not integrating with x's anymore. I'm integrating with u. So mine's probably not 1 to 2 unless it's just a coincidence. So when x is 1, how am I supposed to know what u is? Plug it into what? Very good. So you can just plug it in over here. When x is 1, u is 3. When x is 2, u is 6. Because we have a u, we are going to integrate from 3 to 6. Now, I guess one other change on this type of question is you don't have to plug this back in place of u, because we're just going to get numbers anyway. If you substitute this back in place of u, you need to keep your bounds 1 to 2. For consistency, I'm always just going to leave it u here and make my bounds in place of u. So it looks like we have a -1/4 out front. If I plug in a 6 into this, this would be 36, but it would go to the denominator. Plug in this would be 9, but it goes to the denominator. And of course, if you need to simplify it, you can simplify it. I don't care about the arithmetic today, but the only difference with definite integrals is you need to change those bounds. The original bounds are going to be in terms of x. You need to change them so they match up with u. X equals 1, plug it in here to figure out what u was. When x equals 2, plug it in over here to figure out what u was. As long as you remember that, there's really no difference with those. Okay, we got 2 more with their notes, and then again, it's like a 7-question book assignment we'll do as a group. So with that, I will kind of fill in the gaps, but I will ask you guys the majority of the questions. That also helps me figure out what you're getting and what you're not getting. Okay, so what do we guess u to be? Yeah, number 6. Okay, it's stuck under the square root, so that's probably u. Take the derivative of both sides. Multiply the dx over. All of that stuff can just be automatic. As soon as you recognize that, hey, I can't just do this integration the way we've learned before, it's not just something we've memorized, it's not just undoing the power rule, therefore it has to be u substitution. That's the only other method that we do. So you're going to need this, you're going to need this, you're going to need this, and then you should be close to making the question look easier. So I could say, instead of the square root of this stuff, I could say the square root of u, because that's what I decided to be u. The other puzzle pieces that have to be accounted for is cosine x dx, which is du. So I don't have to do that extra step, like sometimes it's not Sometimes it's not a perfect fit, so I need to do one more step of arithmetic, but in this case it was. And so we're still going to integrate this the same way. We're going to raise the power by 1, divide by the new power, and then evaluate it. But we are not evaluating from pi to 3 pi over 2, because that's when it was in terms of x. We are in terms of u. So you got to plug pi into this statement. When x is pi, u would be 1. The sign of pi is 0. Add 1 to that, you get 1. And when x is 3 pi over 2, u would be the sign of 3 pi over 2, which is negative 1, plus 1, which is 0. So we're integrating from 1 to 0. Not the same thing as 0 to 1, so be careful with that. For this type of question, you should not plug this back in. You should not plug this back in for u, because we're going to get number answers anyway. If you do that, you better keep your balance the same. But first time I'm going to plug in 0, 0 cubed, the square root of 0, all 0. Plug in 1, 1 cubed, the square root of 1 is 1. Subtract those values, and you end up with negative 2/3. Also, something to keep in mind, there are times on the AP exam where they will put this on the calculator portion of a test, and even if you can do this by hand, if you have a calculator, remember your calculator can do this type of question for you. So on a calculator question, I would hope that you would realize that you don't even need to do any of this. Just throw it in your calculator and see what your calculator says. Of course, in our practice, don't do that, but that's a good backup. All right, one more. So in this case, I would pick u to be this stuff because it's trapped inside the cosine. I know I always need this next. I know I need to always multiply the dx over. And then I start trying to make substitutions. Instead of cosine that, I will call it cosine u. The other pieces are x dx. Unfortunately, I don't know what x dx is, but if I add one more line, I can solve it really easily. I need to divide by 2, so I need to divide by 2. So instead of saying x dx, I need to say 1/2 du. Now honestly, you should probably change these bounds right away so you don't forget. When x is 0, u is 1, and when x is 2, u is 5. And now I won't say that the rest of the question is easy for everybody, but this is no different than what you've been doing for weeks at this point. Okay, what can we take the derivative of to get cosine? So 1/2, first time you plug in 5, next time you plug in 1, subtract those. Sine of 5 does not simplify, and the sine of 1 does not simplify. You have to leave those alone. That's all you can do. Those are all just a number. Now, I guess just to follow up on what I said a second ago, if this was a calculator question on your AP exam and you had a calculator and you just threw it in your calculator, it's going to give you some weird, unusual decimal. And if the answer choices look like this, you would need to plug in the answer choices to see which one had an equivalent decimal. So you're not going to recognize whatever this decimal is based on what the calculator says. Okay, so as I said, I want to, well, first off, is there any questions, any immediate questions for 5, 6, or 7? Anything you want quick clarification on? Okay, then let's see. You do need a blank piece of paper. And again, we're doing it together, so you don't really need to copy the full assignment down just yet. I will tell you which questions we're going to look at. On page 337, we're going to start off with question 7. then number 10 after that. Alright, so again, this is like a 7-8 question book assignment. It's half of the one I want you to do, but it's just the half I'm asking you to do today. So, we're going to do this together, and then you can work a little bit more at your own pace when we move on to the Khan Academy. So, you're going to get more of that Khan Academy finished in class the faster we do the book assignment. So, I'm saying that because I don't want to do the majority of the explaining here. I need to be asking questions so I know what to emphasize more. Okay, first thing we need is U. What do you guys think U should be?
25 minus x squared.
Okay, let's try that. The next thing we need is du dx. Somebody else tell me what that would be.
Negative 2x.
Okay, negative 2x. And you always need to multiply the dx over. So we for sure will need to use this, and we hope to use this. Sometimes we need to do one more arithmetic step. But let's rewrite the question. It looks like instead of the square root of this, we could say the square root of u. And all the other pieces would be negative 2 dx. Negative 2 dx is exactly equal to du. So to finish this question, we just need to integrate how we've been doing and then replace u with the x stuff. So raise the power by 1, divide by the new power, slap a plus c onto it, and don't leave u in your answer. Put what u is equal to. Okay, before we move on to question 10, how could I check that? Right, you could take the derivative, and even though that sounds like a pain, it's really just power rule and chain rule. And on a test question, that would be worth your time, I think. Of course, on your AP exam, you got to know power rule and chain rule anyway, so it's nice to kind of review those. Okay, quick questions about 7 before we go on to 10. Okay, this time I would like you to, out to the side, you pick out a U and solve for the rest of the stuff before I tell you what it is. Go ahead and write out the 3 things that you know you're going to need for every question. The next question will be number 27. I only say that for people who feel a little more comfortable and are working a little bit quicker, they can try to stay a step ahead. Okay, so hopefully by the end of class I will at least convince you you need to just automatically do this, and this is trapped under something, this is his derivative, and this is what it looks like when you multiply the dx over. Shouldn't be spending a lot more time than that. I'm not doing anything special. I don't know any shortcut to do those 3 things. Okay, now we need to make this look different. When we do this, all of this x stuff should become u stuff. This is why it's called u substitution. So this can become u to the 5th. I lost this. This is supposed to be x squared. I didn't put this squared there for a second. And I need to know what x squared dx is equal to. Do I know what x squared dx is equal to?
Negative 1/3 du.
Okay, well, so no, but I can figure it out. So this is where I said sometimes you need to do one more step. Write down exactly what you need, think about what you're doing to this side, and do the same thing to this side. If you don't do that, you are not going to realize where the negative 1/3 comes from. Again, that's where it's undoing the chain rule for us. This is creating it as a process instead of like mental calculation. Okay, and now we're basically done. Raise the power by 1, divide by the new power, plug this stuff back in for u. You need a plus c, and I guess we might as well multiply these together while they're there. Again, I'm not trying to be dismissive of the end of the question. It's important too. It's just that you've been practicing the end of these questions for a while, so that's not where my focus is today. If you have time, check by taking the derivative. Make sure you do chain rule so that you see where all that stuff comes from. The derivative of this is supposed to be exactly that. Okay, I'd like to start you off on 27, and then as we go through these, I'm going to ask you to try a little bit more and give me a little bit more feedback. To kind of wing you off of me just telling you what to do. Okay, this one says solve the differential equation. So to solve a differential equation just means take the derivative and figure out what you think the original function is. So we need to integrate this side. Integrating y prime gives us y, which means we need to integrate this side. And we can integrate each term one at a time. So this has nothing to do with u substitution. Don't start doing u substitution all the time now. I mean, probably this class and next class because it's our focus. But it's not like every integration needs u substitution. This is not u substitution. Just raise the power by 1, divide by the new power, and then check to make sure that's your derivative. We don't need u substitution there. But for this guy, we do, because I can't, it doesn't match anything we've memorized, and I can't just do that in my head quickly. It's not just undoing power rule. So for this part of the question, since we're going to need u substitution, I want you to write out these 3 things out to the side, and this time I want you to try to make those substitutions before we say it together on the board. So try to make this look different so that there's no more x's in there. And I'm not going to give a ton of time here because again, I want to get y'all to move on to the Khan Academy so that you can hopefully get at least 2 of those done before you go. But okay, what was u?
16 minus x squared.
Okay, so somebody else, the next step, du dx would be,
Negative 2x.
okay, and so du would be, keep going, du would be, okay, you started to substitute this stuff. Instead of saying over the square root of this, you should have said over the square root of u. And since this is u, you just slapped a du there. Is that what you did? I hope not, because it's not correct. I'm not saying it's correct. The rest of this question is 4x dx. That's the part of this that I have not accounted for yet. I don't know what 4x dx is equal to, but physically write it down as a 4th step over here. Think about what you have to do to this to get to this. I need to multiply by -2. If I multiply the right side of this equation by -2, I need to multiply the left side by -2. So instead of saying 4x dx, you should have done a -2 du. That last step is very important. Looking at this, it's not intuitive that you should be multiplying by -2. Okay, and then now let's finish it together. This is like u to the -1/2. So we could raise the power by 1. Bless you. Raise the power by 1, divide by the new power. Let's see, dividing by 1/2 is the same as multiplying by 2. We need a plus c there because this is an indefinite integral. And then what should be my last step here?
Plugging in the
Right. Your answer shouldn't have anything to do with u's. And I guess -2 times 2. We really should do that too. Optionally, you could change the exponent of 1/2 back to a square root if you want to. Mathematically, those are the same, so it doesn't really matter. But okay, moving on. Next up is 33 and then 34. These two are a little bit more straightforward in my opinion. So I'm going to ask that you try both of these. Honestly, both of these are only undoing one step of chain rule. So over time, you might feel comfortable enough just doing that in your head without doing the u substitution process. But the u substitution process is the process that works 100% of the time. So try both of those and see how far you get until you feel stuck. And then I will go over both of those with you. And for those of you that are feeling confident, you're welcome to try to stay a step ahead by doing 55 after that. Okay. You guys finished with both those or close to finished with both? Okay. So on number 33, I'm going to not ask any questions here. I'm just going to go over it. So feel free to interrupt me or ask at the end. but you probably should have picked pi x because it was stuck inside the sign. This is not sine times pi x, it's sine of pi x. You need this so that you can solve for this. And then you can start looking at trying to make this look simplified. This is now sine u. And the other parts are pi dx. I know exactly what pi is. Pi dx is this question. It is du. So sometimes you need to do one more step, but this question, it was a perfect fit. All right, now you gotta be careful here. What can we take the derivative of to get sine? Very good, negative cosine. Because the derivative of cosine is negative sine. So taking the derivative of this gives me negative sine, which is positive sine. Plus c, and don't leave u in your answer, plug u back in. High stakes question, check by taking the derivative. Okay, 34, looks like u should probably be 4x for a similar reason. You need this so that you can solve for that. Then when you start to try to rewrite this and plug everything in, this looks like sine of u. But the only other puzzle piece here is the dx. And I don't know what dx is equal to. I need to divide this by 4, so divide this by 4. If you did not get a 1/4 in there, you need to follow through on that last step. Physically write down the rest of the pieces that you need to substitute. Then you can see what has to happen here to realize what has to happen here. Okay, and then the thing that we can take the derivative of to get sine, well, we just talked about that. That would be negative cosine u. You have to have the plus c because this is an indefinite integral. I don't know, we can talk about this later, but sometimes in calculus classes people make up like silly names for c. A couple years ago we called it crab. Don't forget the crab, just something silly like that so you guys remember. But make sure you plug in 4x for u in your final answer. Check by taking the derivative. Yes, sir.
On 33, is it not different with the pi since it's outside of the equation?
What about it?
Like when you did du equals pi dx, usually like the pi would be inside of the...
Well, pi is a constant, so whether you write it right outside or right inside is the exact same thing. So it doesn't matter where that is. So if it bugs you that it's there, you can squeeze it back there if you want to. You still should be making the same substitution. Just like derivatives. If you want to know the derivative of f of x, it could be one thing, and then if you want to know the derivative of 3f of x, it's going to be the same derivative times 3. So integration, the same thing. Whether you do the constant inside the integration or outside, it's changing at a constant, so it's just going to make it that much bigger, that much smaller. So, okay, so again, I just kind of flew through those two. What other questions can I help with? It's fine if you got stuck, it's fine if you make a mistake, but again, you got to try to learn from that mistake because you'll just keep stumbling over that same thing until you get it cleared up. Okay, then let's keep going here. I think we got just a couple more. 55 gives us a derivative and a point, and they are asking us to find the function. So if you're trying to go from derivative to function, you should be integrating, and it needs to go to this point. So all that really means is our answer shouldn't say plus c. We've got enough information to actually solve for a numerical value of c. So you will need to, integrating this becomes this, integrating this looks like this. So you need to do u substitution to try to finish that. Okay, so again, just for some variety here, Your guess for u should be what?
X over two.
Okay, probably x over 2. So that means this is 1/2, which means du is 1/2 dx. And then you hope that this and this allow you to rewrite that. So instead of saying sine of x over 2, we can say sine of u. And then the other pieces we need to account for is a negative dx. I don't know what negative dx is equal to. I know what 1/2 dx is equal to. So again, please don't do this in your head. Write down what you have. Think about what has to change here. I need to multiply this side by -2, which means I need to multiply this side by -2. Instead of saying negative dx, we're going to say -2 du. Okay, and the thing that I can take the derivative of to get sine would be negative cosine. Okay, and so for this question, I'm going to just leave a lot of stuff off at the end. What else did I forget?
Plus C and plus.
Okay, so don't forget the crab. What else?
You expose the
What about this guy?
Oh, sorry.
Let's go ahead and put this back in place of u. And then finally, you can use the point. This point just gives us enough specifics that we don't have to leave our answer plus c. We know when y is 6, x is 0, so c must be 4. So the real function that has that derivative and goes through that point would be 2 cosine x over 2 plus 4. Again, I'm not saying that this process is easy or this question is easy, but you have to at least appreciate you trying to do that on your own in your head. Tell me what the function could be that has that derivative and goes to that point. You're going to spend all day trying to figure that out in your head. Whereas u substitution, you jump through the process, make the changes, and finish with the stuff we've been practicing. And at least you'll be going to be finished in a couple minutes. All right. Anything you want to ask about that one? Okay, last two would be 72 and 74. So these are a little bit different because these are definite integrals. These have the bounds in them. So remember, we have to do something about those bounds like we did on the bottom of the notes. None of the questions we've looked at have been definite integrals until this one. So at this point, I think most of you guys would probably pick this out to be u. I think I hope that I've convinced you that you need to go through those 3 steps. Just do them right away because you're going to need them. I think you should be starting to see that these are like puzzle pieces to try to replace this. So instead of this, we could say the square root of u. And what can I replace instead of x dx? Very good. X dx is -1/2 du. I divided this side by -2, so you divide this side by -2. You don't need to try to make it more complicated than that. Sorry, I need to start using something different here. I know that's hard to read. Okay, the reason why I'm walking you through this one instead of asking a bunch of questions is you got to be careful on this question type. 0 to 1 is if you're talking about x's. When x is 0, u is 1, and when x is 1, u is 0. So we should not be integrating from 0 to 1, we should be integrating from 1 to 0. I would suspect, I don't know this to be true, but I would suspect on AP level questions, they probably one of the wrong answers is not remembering to switch those bounds. They probably leave that as a distractor answer because that would be common. Okay, then you can integrate this guy as normal, raise the power by 1, divide by the new power, plug in 0, because you always plug in the upper bound first. You don't plug in the bigger number, you plug in the upper limit first. Then plug in 1, subtract those. In the end, looks like you get 1/3. However, if this was a calculator question, you should just plug it in your calculator only. Don't take the time to do it just because you can. Okay, so the main thing I'm worried about on this question is these bounds. Are you guys okay with why 0 to 1 became 1 to 0?
Yes.
Okay, then try one more for me, which would be 70, what did I say, 74? It's the last one from this part of the book assignment. And this one I will give you a couple minutes head start so that you can see how far you get in that amount of time and where you start slowing down. This should really help. At this point, you should have a good idea of what you think is challenging. Actually, I'm going to give maybe another extra minute or two than I was expecting. Those of you that feel like you've got this and you feel like you have an answer that seems right to you, if you have a calculator in front of you, feel free to throw all that in the calculator. And if you got the right answer, you can tune me out and move on to the Khan Academies. You don't have to wait for us if you've got the right answer. That way I'm not holding you back. And there are 3 Khan Academies, but again, one of them should be very quick. One of them is just asking you to pick out what you think you should be. So please start with that one. And then one of them is on definite integrals and one is on indefinite integrals. You can do whichever one you want to in those order. And where? Okay. Thank you. Looks like the calculator is saying the answer to this should be 1. So even if you're not finished, you at least see where you're slowing down. So it is fine to pick a wrong u. You usually figure it out pretty quickly, but I would guess this for u, which makes du be 4x dx. Rewriting this, instead of over the square root of this, I can say over the square root of u. The other parts were 1x dx. I have 4x dx. I gotta divide this side by 4 to get what I need, so I gotta divide this side by 4. 1x dx is the same thing as 1/4 du. You should not be integrating part u's, part x's. I think that's called integration by parts, and that's a big part of Cal 2, but it doesn't show up in Cal AB. The other thing that you really need to emphasize here is these bound changes. It is no longer 0 to 2. 0 to 2 if you're talking about x. We're talking about u. So when x is 0, plug it in over here to see that u is 1. And when x is 2, plug it in the same thing to figure out, I think that's 9. And then you need to finish it the normal way. Maybe rewrite this. Raise the power by 1. Divide by the new power. Don't plug this back in place of u. You have to do that if it's a indefinite integral, but with the definite integral, leave it alone. If you plug 1 plus 2x squared back in place of u, you need to keep this 0 to 2. Leave it 1 to 9 and leave it u's. So we end up with 1/2 times, plug in 9, you get 3, plug in 1, you get 1. Subtract those, you end up with 1/2 times 2, which confirms with what the calculator said. Comes out to be 1. So again, it's not that u substitution is like an impossible process or anything, but if you don't practice it enough, or you try to take shortcuts, then it does become a skill that you always will be frustrated by. And again, this is really important. Our next assessment, I think last year, like 5 of the questions were u substitution or something. Several, quite a bit. Okay, I will ask for this in the future, so of course you need to keep it in your binder, but is there anything you guys would like to clarify while it's still up? Is there any part of it that you know you don't understand that you need to just get cleared up now? Okay. Then you've got 3 Khan Academies. So again, please do the one about picking u first, because that should be the easiest and quickest. That one shouldn't take you too much time. And if you're struggling with that one, you're going to struggle with the other 2 also. So do that one first, and then you can do whichever of the other 2 that you want. I'm sorry, there is one other thing I want you to quickly write down though. It just, you guys know you get different questions on Khan Academy depending on, you all get different questions, but one of them you might get requires you to know this, and I have shown this to you before, but I didn't tell you you needed to memorize it yet. You still don't need to memorize it yet. I will warn you before we put it on a test, but you might see a question that looks like that, and one of the answers might look like something about inverse tangent. So jot that down just so that doesn't hold you up too much there. I don't know, like, do something else. It's supposed to come with it charged. You can use your phone too if you'd rather, but you need to. Okay, of course on the Khan Academies, if you miss a question, you should click the Get Help so you can see what went different. And if you're not sure after that, then please let me know. You are also welcome to, on the definite integrals, don't use your calculator to get the answers, but you're welcome to check your answers with the calculator before you submit your answer. That way you might be able to find a mistake and not have to restart that one. But I do need you to practice enough that you can get 100 on each one. And you got 25 minutes of class. Yesterday I think they did it roughly about the same. You guys might be a few minutes ahead. And I would say most people got 2 of the 3 done, so they had 1 for homework, but there were a few people that got all 3 done. So depending on how confident you are and how quickly you'll get focused, you could potentially not have homework. Going okay? Anybody got something I can look at and help you with? Trying to help paper?
Very good.
Okay. Pretty much, yeah, just get to you, solve for DU, and then usually it's gonna look pretty similar to what you have, or it's not. So in that case, if you pick, it's fine to pick something wrong, like it's better to pick something wrong and then realize it's wrong than just pick something else. But on that one, you pick secant to DU, the derivative of secant is secant tangent. See what I'm saying? Oh, so that's close, but it's not gonna be tangent squared. If you pick tangent to be u, what's the derivative of tangent? Right, so this could be like u squared, and then the derivative would be the secant squared part. So, yeah, that's hard to know. It's fine to pick the wrong u. Sometimes it's not gonna be easy to know which one to use, but you gotta set something.
But this is the first one.
Yeah, insurance. Or you can put parentheses and put the force, that should be fine too. The only thing you wanna be careful is not putting parentheses and doing that, cause then computers and calculators think you wanna raise x to the fourth and not do sin x.
Yeah, we're using one sentence like that.
Yeah, so there's this thing called caret key, I don't know why it's called caret key, but do that, and that's an easy way to do it.
If I have this as my u substitution interval,
Okay.
does this just become u to the 0 power and then it's just 1 and it's just -4 times 1?
Okay, so you're trying to undo power rule, so if you raise the power by 1, you get 0, and then what else do you need to do by that?
Oh, multiply by 0, so you just say 0.
That's not how we how we undo power rule. You raise the power by 1 and divide by the new power.
Right, that was so undefined.
Well, no.
Okay.
But it doesn't work, right?
Yeah.
The reason it doesn't work is because if we could just undo power rule here, we wouldn't need one of our other things. This is one that you have memorized. Pretend like it says x. What can you take the derivative of to get 1 over x?
Natural numbers.
Exactly. And that's why we need that property, because you can't just undo power rule into that exponent. Or natural log of absolute value, but. Yep. Again, I think there is 1 or 2 where you may not feel 100% comfortable about what u should be. My best advice is to just pick something, solve for du, and if it looks like it's right, run with it, and if it doesn't look right, just pick a different u and start over. Sometimes it's not possible to just guess what u is going to be without planning it out a little bit.
Well, I did the first one, but I'm working on something for Spanish.
You gotta do this now. You can do that another time. Sorry. I wouldn't ask you to do math in Spanish, so.
It goes right out Austin.
Spanish.
You're supposed to write it like up here.
They use the same numerals, unless you're asking us to write out the whole word.
You just put it on the
Well,
board one day.
if you want credit for Roman numerals, I guess, but if you want credit for calculus, you gotta do calculus.
Oh,
Yeah, in class,
Wait.
the Spanish class.
in Spanish.
Yeah, not in the language.
Yep.
So, I got, I had this written down, but instead of doing the natural log, I just moved it to the 1/2, and that's what I was doing for the other questions.
Yeah, but raising to the 1/2 is when you have like a square root. You don't have a square root here.
Alright.
Square root's the same as 1/2. This one, she was asking, Harper was asking about this one a second ago. So it's tempting to write this. This is pretty similar to what you had. So if you write this like this, and if you try to undo the power rule, where you raise the power by 1 and then try to divide by the power, that should give you an issue because you know you can't divide by 0. And the issue is, this isn't undoing the power rule. This is one that we have memorized. If you want 1 over x or 1 over u, that's where you use natural log.
Okay.
And that's why we need that property, so.
What is that?
Certain, like, antiderivative of certain gives you trigonometric functions. That's called arctangent. It's
Ln
weird.
x is 1 over x.
That's really weird.
Oh, so.
It's we've been hearing on different things, it's just, it's been a while. Maybe it's never really.
UV on this one.
I would make u be x to the fourth. Because it's stuck in the exponent of u.
Okay, that makes sense.
And then plus if you rewrite
If you
that,
rewrite it like
the thing
this.
you can take the derivative of, you get e to u raised to u. That's pretty easy to do too.
Okay.
We're still got about 8 minutes, so try to get a little bit more done, please. Maybe try to finish up the one that you're on before you call it quits today. There was one thing, good news, bad news, I wanted to mention to you guys after the test last time, and then I forgot. So I hope to have the test grades in today. I'm just waiting on Miss Cross to confirm that we're going to go with the standard curve. I didn't want to put all that in and then have to recalculate all of that. So hopefully those will be in the grade book today. Bad news is, first semester you guys had a grade replacement at the end of the semester on the semester exam, but we don't do a semester exam this semester because you have your AP exam basically at the end. It doesn't make sense for you to do a test after your AP exam. So you don't have that grade replacement in the form of the final exam this semester. However, we do have one grade replacement opportunity, and it is on the next assessment. It's the only grade replacement opportunity we have this semester. Last semester you had 2. I think we did chapter 4 could replace your 4.1 through 4.4 if it was better, and then your semester exam could replace one if it was better than something. This semester the only one is the one that's over chapter 5, which is what's next. Chapter 5 includes the stuff that you just tested over, 5.1 through 5.4, and use substitution. So if you wish you had studied more, if you realize there were some questions you should have practiced more on the test, you probably still need to go practice those because those are still fair game for the next assessment. But we do give you that opportunity that if you didn't quite make the dots connect, if you get it together by the next test, then you can override that first test grade with the second test grade. So. Hopefully that's a little bit more motivation to finish chapter 5 strong. And then again, we only have 2 units after that. Chapter 6 stuff is probably the easiest test we do all year long, first or second semester. And then we only have one other one that has like 4 or 5 skills, but I don't know. They're not the easiest, they're not the hardest, but they're also the last ones. So it's kind of easy to finish strong. So. And then after that, we can just focus on practicing FRQs and reviewing and rememorizing everything and talking about the AP test and scoring, and just try to prepare for that a little bit each day. That's the plan, at least. Okay, now you guys are down to about 5 minutes, so feel free to find a good stopping point. This is an A week, so I will not see you guys tomorrow, which means you have until the start of class on Tuesday to finish these up. Again, if you can get them in one go, that is great. If you need to practice it 10 times, then you need to practice it 10 times. As I said, it doesn't take a million questions for you to kind of get the process, but it does take a lot of practice before you can do it reliably. So if you didn't write this down that's on the board, though, I would probably jot that down on the top of your page in case you see that Khan Academy question later. I wouldn't want you to have to restart the whole thing because of that question, but if you don't do that, then you might.